Hey everybody, wanted to make a video to help go over the practice quiz for the current resistance Ohm's law quiz, open Wednesday. So to take a look at the practice quiz, number one, radio operating at 3 volts in a constant temperature draws a current of 1.8 times 10 to the negative 4th amps. What is the resistance of the radio circuit? So we got voltage, 3 volts, so V, 3 volts. What else we got in the problem there? Current I, so current 1.8 to the negative 4, 1.8 times 10 to the negative 4, and that would be amps, of course. And it's asking for what? It's asking for resistance. I think I know what to use. Let's check out the notes real quick there. Boom, there it is, Ohm's law, V equals IR. So I'll plug it in. So we've got 3, 1.8 times 10 to the negative 4, and we're looking for R. Divide yourself over there. And solve for R. And when you solve for R, so when I solve for R, what do I get? Well, calculator spits out calculator spits out 16666.7. And out of those choices, it's in scientific notation, so it's rounded. So they're rounding to 17000, so 1.7 times 10 to the 4th ohms. And let's see if that is, yep, there it is, number 1. All right, so number two, the resistance of a circuit remains constant. Which graph best represents the relation between current and potential difference? So current and potential difference. So I'll just save this Ohm's law right there. So it wants to know the relationship between potential difference, V, voltage is another word for potential difference, V, and current. So if this stays the same, if one goes up, the other one would have to go up to stay the same. So that's a direct relationship. So if you look at all these pictures here, I see a direct relationship here in number 4. All right, number 3, which change decreases the resistance of a piece of copper wire? So let's just check out in the notes here. I pulled that out. So factors that affect resistance. So longer is going to make it harder, so it's going to be more resistance. Cross-sectional area, thinner is going to make it harder, so bigger diameter is going to be easier. Temperature, warmer is bad, cooler is better. Warmer is more resistance, cooler is less. And then conductivity, I actually grabbed a chart as well, just something generic. It's just conductivity is based upon it's a characteristic property of the material, so generally a metal, right? A conductive material. So you would need to access some sort of chart or something like this. We won't need to do it for the quiz, but just to kind of go over what that is. So you go to resistivity, and it's in a certain value here. So anyway, so back to the question there. So which changes decrease the resistance? So increasing the length, 1, nope, that's going to make more. Increasing resistivity, nope, that's not good either. Decreasing the temperature, that is something that will decrease resistance. Let's keep reading. Number 4, decreasing the diameter, no, that would help. So number 3 in there, decreasing the wire's temperature, is going to decrease the resistance. So we're looking for 3 is number 3. Let me just peek down at the bottom here. 3 is number 3. Number 4, an electric circuit consists of a variable resistor, so something that you can adjust the resistance. This might be something like a dimmer switch or a electric throttle of some sort. Anyway, potentiometer. Connected to a source of constant potential difference. If the resistance is doubled, what happens to the current? So V equals IR. So if resistance is doubled, so if this got twice as big, what would have to happen to this for this not to change? Well, that would have to be half what it was. Those are inverses to each other. So we're looking for half to answer number 1. Number 5. Current through a 10 ohm resistor is 1.2 amps. What is the potential difference, or what is V, voltage, potential difference? So we have 10 ohms and 1.2 amps. So we've got 10 ohms, that's resistance. What was it, 1.2 amps, and that is current. And what is it asking for? Voltage again? Yeah, potential difference, voltage. So V equals IR. So we're just looking for the product. 1.2 times 10, easy peasy, times 10, looks like 12 volts. And there it is, answer 2. Number 6, a 6 ohm resistor. It's obeying Ohm's law, okay. It's connected to a variable voltage again. So when the applied voltage is decreased from 12 to 6, so that'll be halving the voltage. What happens to current when you half the voltage? So what would happen to current if you half the voltage? So if you half the voltage on this side, what would happen, if this remained the same, what would have to happen to this to remain equal? That would have to half as well. Voltage, potential difference, and current are a direct relationship, so halving. So let's see, that was 6, so 6 is 3. Let's just double check that. 6 is 3. 7, flashlight. Battery provides a total of 3 volts. Flashlight is operating at 5 ohms. What is the current? So it looks like another Ohm's law. V equals IR. And what is it saying again? 3 volts, 5 ohms. So 3 volts, 5 ohms. Wants to know current. Divide yourself over there. I, 3/5 of an amp. 3/5 of an amp. And that must be option 2. 7 is number 2. Double check. Yes. 8. How much current flows through a 12 ohm flashlight bulb operating at 3 volts? Another V equals IR. How much current? So I we're looking for. So 12 ohms, that's resistance, and 3 volts, that's voltage, potential difference. So 3 volts, current, and 12 ohms. So divide by 12, solving for I, looks like 3/12. And that must be answer number 1. 8, double checking, is number 1. Number 9. Incandescent bulb is supplied with a constant potential difference of 120 volts, so a household light bulb, old style. Filament heats up, and its resistance what? So heating up is bad. So you get the internal motion or kinetic energy of the molecules inside going, and that's going to make it harder for the electrons to pass through. So let's see. So as it does warm up, what's going to happen? So its resistance increases. Yes. So that gets rid of option 3 and 4. So it's going to increase the resistance, and then current is going to decrease. That must be option number 1. Heat up is going to be bad. So if you heat up, that's bad. More resistance. You're just still connected to your normal voltage. That doesn't change, the 120 volts. So that means current would decrease as it warms up. Number 10, let's just double check. 9 is 1, and 9 is 1. 10. Almost done. 10, copper wire is part of a circuit. Which graph below represents the relationship between the wire's length and resistance? So length and resistance. Let's just think about it real quick. Length and resistance. So as length goes up, resistance, that's bad. So as length goes up, resistance would go up. So let's see again. Which graph represents the relationship between length and resistance? So as one goes up, the other goes up. I only see one graph doing that, so 10 must be letter number 2. 10 must be 2. It is. 11. If the diameter of a wire were to increase, what would happen to resistance? So just to think about it again, so diameter, so thickness. So if diameter were to increase, that would what would happen to resistance? Resistance would go down. Thicker wire, less resistance. So let's see, if the diameter would increase, resistance would decrease. 11 is 1. And one last resistance question here. Let's see here. Which copper wire has the smallest resistance? So we're looking for a fat, short wire. So looking at the options here, fat would be twice the cross-sectional area. So we're looking for one of these choices, and then the shorter one is going to have less resistance. So 12 must be 3. Let me double check. It is. All right. So that was the run through of the practice quiz. Ask any questions in the chat, and I'll talk to you later.